All right, this is the video for how to do the titration lab. It's kind of the same for all titrations. So let me move over there so I can show you how to set this up. So the first thing you need is to grab a ring stand. They look like this. Here it is. And they look a little bit different sometimes, but basically it's a big rod. It's got little feet on the bottom. And you're going to use this to hold your burette. Burette is a long glass object. It looks like this. You just pull it and clamp it in. A couple of features. It is glass. It's about $200, so don't break these. And then here, get a piece of paper for contrast behind. So here's the stopcock. When it's turned sideways like this, like pointing at us, the liquid that's inside does not pass through. When I twist this so the blue knob is up and down, the liquid will drip, 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 drip down into a container. So right now there's a little bit of liquid in the container, but I need to fill it with more liquid. And what we're putting in today's is going to be base. So it's labeled B at the top. Using a funnel, I'm going to take the base. And for this experiment, the one I just set up, it's 0.25 molar base. I'm going to fill it up, not all the way, but that's going to be good enough. So let me try and zoom in here on how high it is so you can see the lines. So it's got little tick marks, and I'm going to do my best to read down here. It's like 9.5 is where it's filled to. I need to keep track of that number, 9.5. Down below, let me get the base out of the way so you can see. Down below, we have a little beaker. This is where we're going to put our acid. I honestly 100% do not know the concentration of this acid. I just kind of took some water, diluted it, mixed it. Now what I'm going to do is measure. You'd want to do this more exactly. You'll have better apparatuses when you do the lab, but about 20 milliliters of acid. So you'll use a graduated cylinder to be more exact for better results. Measure 20 milliliters of acid, put it in there, and now we're almost ready to start the experiment. The last thing I need to do is add a few drops of what's called phenolphthalein into the beaker. What the phenolphthalein does is it turns purple once it comes in contact with something basic. So right now, the acid is clear because the acids and bases are usually clear. And even when I add several drops, maybe like 3 drops of the phenolphthalein, it still stays clear because it's acidic. Acid plus base are going to neutralize, and I'm keeping track using this little titration. I'm going to keep track. Oops.
Hey, Rand will be back in 30 seconds for your end of the day announcements.
Sweet. All right, while that announcement is going, I took some time, I set up some paper here to make sure we understand what's going on. So I've got 20 milliliters of acid. This is the formula. I have, I don't know how much base I'm using. I need to measure it, but we're going to go from 9.5, because that's where I filled it, to blank, left us a space. And I know that the concentration is 0.25 because I got it out of a bottle. So here we go. I added some indicator, and now we're ready to perform this titration. So the stopcock is this way, facing us, so it's not dripping. But if I turn this, let's see, make sure that's going to fall in the right spot. If I turn this downward, you can see it start to drip in. Now it's turning pink right away because it's the base from here is dripping in and making it turn pink. But when it mixes, there's still a lot of acid in there. So I swirl, swirl, swirl to make sure that it's all mixing together. So I continue to drop the base, swishing, swishing to make it go away. Because as long as it keeps making that pink go away, then that means in this container, there's more acid than base. Once it stays pink, I've put in too much base, but I can use the amount that drips to solve the problems through. So I'll continue dripping. And you kind of either got to drip slowly, drip, 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 and stir quickly is the most effective way to do it. But since we're recording and I don't want to be here forever, I'm going to be a little bit irresponsible and reckless and have it drip really fast and then make sure it clears. But the longer that that pink lingers, the closer I am to almost being perfectly neutralized. And I don't know if that one's going to go back. Maybe? No. Okay, it does not. Now, I did a boo-boo. I did a bad job. This pink is not what we're looking for. I put in too much base. I should have drip, drip slowly and stirred it so I could get a light pink color. That's what we want. This dark pink color, that's... you're just not going to get as good of results because you put in too much base, not exactly enough base. But that's okay. Everyone makes mistakes. So if this happens to you, just start over, do it again. Okay? Until you get pink. Discard your data, start over. Okay, looking at this now, it went from, it was up here at 9.5 and it dripped all the way down to 17. So from 9.5 to 17. With this data, I'll show you what you're going to do to calculate the concentration of the acid here in a second. Okay, I'll show you the calculations in a moment, but what I've done is I restarted the experiment and I just want to, the only point of doing this is to show you a better technique for when you get close to the end. So get your drips real slow and make sure to stir, stir, stir to make sure it goes completely away. At the very end, it'll just feel, oops, like one drop at a time. Ooh, oh, that one was really close, but we saved it because it went back. See if I can get just one singular drop. Sometimes it's so hard with the stop cooks. Okay, there's 2 drops. Does that fade? No, it does not. Not. You keep stirring. Double check. All right, I think that's good. So this is the color that you're more trying to get. You're trying to get this light pink because that's like exactly where you've got the same amount of acid and base. If you keep going, if you do what I did last time and you just whoop for funsies, then you'll have added way too much base and you won't have good data. Okay, so here's the data from the lab. We got 19, we went from 9.5 to 17. So calculating the difference between those two. So let's see, 17 minus 9.5. Nope, wait, did I do that right? No, I didn't. Haha, wrong way. So, did I do that? Why am I being such a dum-dum? I love it too, because it's recording. It's Monday. If I start at 9.5 and went to 17. No, I did that right. I'm just psyching myself out. Okay. 7.5. we used 7.5 milliliters in the titration. And that's how much we used of the base. So doing these calculations, 7.5 milliliters converted to liters. If you cough during this video, no one will care. It's okay. So that's how much base I used. I used this much NaOH. The concentration is 0.25 molarity. This was the acid that was used in the lab. 1H combines with 1OH to make water. Following this through, this is how many moles of the acid that was in the container. Because highlighting according to the colors that we usually do. Blue for base, 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 base. Second parentheses is the switch. Acid, answers in moles of acid. So if ultimately the question that we're solving in this lab is what is the concentration of the acid, and we need to take the moles of the acid, divide it by the liters of acid that we used. At the beginning, I said to pour 20 milliliters. Mine was actually about 21 milliliters. So converting 21 milliliters into liters, 0.021 liters, 0.021 liters, and 0.001875 moles per liter. This tells me that the acid concentration before I did anything to it was 0.089 molarity. Ta-da.